B10, the law of cosines. This law is related, you'll see, to the Pythagorean theorem in the sense that this is a more general formula that will reduce the Pythagorean theorem. So here we're going to look at a triangle that has sides A, B, and C, but this is not a right angle. So it's a general triangle that has there's three angles, and what we're going to do is we're going to do another case where this slants out the other way. We call that obtuse. This is acute, so we're going to do the acute case first where the angle theta is acute. That means less than 90, and then we'll do the other case and see what the formulas tell us. The trick here is to drop down a perpendicular like this and then call that height h. And then here, if we make this b all the way over like this, then we could divide this up into two sections where x is this small section and the remaining section is b minus x. And then the total section is, if you add x and b minus x, you'll get b, the total section here. So we can say right off that since this is a right angle, this is a right triangle. So if that's a right triangle, we can then use the Pythagorean theorem. C squared is going to be h squared. We'll do this side first, square it, and then we'll take the next side and square it and add together. All right, so we have that. Then for this other triangle here, the hypotenuse is a, so a squared would equal x squared plus h squared. I'll write the h first. H squared plus x squared, like this. Now what I want to do is take this, see what this h is going to be a squared minus x squared, and I want to put that in for this. I want to get rid of that h. All right. So if I do that, then I will get c squared is equal to, substituting for h squared, I write this down, a squared minus x squared. But I have another piece here. I have this b minus x squared. Now I would like to write out what this is. If I write this out, this is the binomial, we square it, we review this, but let's go ahead and work it out. B squared, and then you have here 2bx with the minus sign. That was what we had worked out before. So I'm using that result here. So minus 2bx, and then plus x squared. Now notice that this x squared here will cancel that x squared. All right, so I'm going to do that and see what I have left. I have c squared is equal to a squared, and then I have plus b squared, and then I have minus 2b times x. At this point, it would be nice to have the formula in terms of a, b, and theta, because see, I can get that x, this x is equal to a times the cosine of theta. Remember that the cosine is you take the adjacent side and you divide by the hypotenuse. The sine of theta would be the opposite side, h, and divide by a, but I don't want that. I want this one here. So when I do that, I get c squared is a squared plus b squared, and then I would have minus 2, and this would be for x I would have the A cosine theta. So it's B times A cosine theta. I will write the A first. AB cosine theta. And this is the law of cosines. You take A squared and B squared, the two sides, and you square them together, and you subtract A times B with the 2 in front, and then the cosine of that angle. And if that angle should get bigger and bigger, so it's 90 degrees, then the cosine of 90 is 0. And you then have just this part, which is the Pythagorean theorem. So it reduces, because the Pythagorean theorem applies to right triangles. But we're not finished yet, because we should consider a triangle that has this angle larger than 90 to have like both cases. So I'm going to do dot 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 here and dot 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 there, like there. So this is the height H, and this is A again. The A just goes the other way. This is still C, and this is B, and we can still call this X in here, this little distance in there. So our angle, though, is this theta here. This is a different angle, and we'll call this angle here phi. All right. So now we're going to do a similar thing here. What we're going to do is we're going to look at this big right triangle. Since this is 90, we could say c squared equals h squared plus this long one squared, which is the b plus x squared. See, before we had a b minus x, now we have a b plus x. And here, this a squared is equal to h squared plus x squared. This is a right triangle, also the baby one. And this is kind of cool that this is the same formula we had there, and this one is the same as that one, except that there's a minus sign in front of the x. So we're going to do the same thing here. We're going to take this one to solve for the h squared and get a squared minus x squared, and then we're going to substitute that in for the h. We're doing the same steps. So then we're going to have c squared equals, for the h squared, we just copy this, a squared minus x squared, and then plus this here, like we had before, with the minus sign, we now have the plus sign. And then we looked at this like we did before, worked it out, and you can see that with the plus sign, everything's going to be the same except for that cross term, where the b and the x are multiplied. So this is going to be b squared plus 2bx plus x squared. Now, once again, x squared will cancel that x squared like it did before. And what we're going to have here, similar equation, but just with the plus sign. C squared is a squared plus b squared, and then plus 2bx. And now when I substitute in for x, if I substitute in for this phi angle, because that's the natural one, see, x is a times the cosine of phi. So if I do that, let's do that, c squared is a squared plus b squared plus 2, and for the x you put in, for this x we're putting in a times the cosine of phi. So that we would put the a first, ab cosine of phi, but I really want the angle theta in the formula. I want, a, b, and the angle between them, just like here I had a and b and the angle between them for that. So how's the cosine of this theta related to the cosine there? Well, now, you really should always go to the unit circle when you have something, say, bigger than 90, you're not sure what to do. If we go here to the unit circle, and we have this angle that's coming up like this. We want to know what the cosine is. See, that cosine is going to be negative when you work at the angle, that large like that. But see, if you had this small angle in here, which is phi, this is the same distance as here. It's just that when you're doing the cosine of the bigger angle, it's going to be minus that. So that's going to be c squared equals a squared plus b squared minus 2ab cosine of theta. Now we're very excited because that is the same formula as we had earlier. And in this case, if we decrease the angle theta so that we get a 90-degree angle, then we'll get the cosine of 90 is once again 0. This will drop out and we'll have the Pythagorean theorem. So the law of cosines, you can think of it as just one formula. Doesn't matter what the triangle is. You take the side that's here. Well, it doesn't really matter what you do here. You could take anything. You just square a side, and then you add the square of the other two minus the cosine between them. That's wonderful. So here you could pretend that's the one you're going to say. A squared would equal c squared plus b squared minus 2cb times the cosine of the angle there. It's general. Amazing. Very beautiful formula.